In this video, we are going to start on chapter 10. And chapter 10 is primarily dealing with bonding. Okay? First thing we're going to talk about is what we call Lewis symbols or Lewis dot symbols. Lewis symbols. And they're a really simple way to represent elements with just their valence electrons. And if you remember me talking about valence electrons, you remember me talking about the fact that they are kind of the business end of the atom. They're what does all the reacting. So that's what we're really interested in. So if we just go across that second period and we start with lithium, lithium has one valence electron, so it has one dot. Okay, and we move on to beryllium. Beryllium has two valence electrons, so it gets two dots. And we don't pair them until they have to be paired. And we kind of put them in a box around the element, you'll see. Okay, next up is boron. Boron has three valence electrons. So we have three dots. Next up is carbon. Carbon has four valence electrons, so we give it four dots. Okay, notice they're not paired, but now with nitrogen, we start to pair them. Okay, and this will make more sense as we start to use this. This is just an introduction for now. So there's nitrogen. Oxygen, six valence electrons, six dots. Fluorine, seven valence electrons and seven dots. So notice they're kind of going in a box around the element. And finally, all the way on the far side of that second period, we have neon with 8 valence electrons. And that is what we call a full octet. And a full octet is what everything's trying to achieve. Remember when we did the electron configurations for ions, everything was trying to get to be like that nearest noble gas, which gives it an octet of valence electrons. So let's write that down, the octet rule. You may remember this from another class, which is good. That just says that elements usually undergo reactions that leave them with 8 valence electrons. Pretty simple. And as with every single rule I give you, I got to give you the exception. And that's except hydrogen. What does hydrogen want? It wants a duet. And why does hydrogen want a duet? Oops, except, can't spell. Because hydrogen wants to be like its nearest noble gas, and its nearest noble gas is helium with those 2 valence electrons there. Okay? And we can also draw these Lewis symbols for ionic compounds. If we think about a reaction like sodium, it has 1 valence electron, plus, doing a different color here, plus chlorine, it has 7 valence electrons. Oh my gosh, that's 8. Okay, can't spell, can't count. So when they react together, what do we get? Well, the sodium transfers its electron to the chlorine. So we get sodium, and you know all this already, sodium with a plus charge and no valence electrons, or really it does have valence electrons, but we don't show them in this symbol because it's given up that 3s1 electron. So maybe we should just say that We went from 1s2, 2s2. Well, let's do this. Sorry. Let's do neon. Let's use the noble gas abbreviation. Neon 3s1. And now it's just neon. Okay, so it lost that valence electron. That's why it looks like that. And then chlorine has all of those, and then it also has this one valence electron that it picked up from the sodium, and we put that in brackets to show its charge. Okay, well, along with all those electrons. So that is Lewis symbols in a nutshell.